Page 3, again, this is Robinson annulation chemistry. And again, this is just to get you guys to practice Michael addition, know what a Michael addition is, know what an aldol condensation is. It's very important that you know those two things, okay? And Robinson annulation questions are good ways to practice. All right, so even though it isn't a classic Michael donor, just like acetone on the previous page, the enolate of cyclopentanone can still add into an alpha-beta unsaturated carbonyl in a conjugate fashion. Provide a reasonable arrow-pushing mechanism and the final product for the following Robinson annulation. Any proton transfer steps can be abbreviated. Okay, so again, you need to know what a Michael reaction is in order to do this, right? Now, a Michael reaction involves some sort of enolate, usually. The only exception would be the dialkyl cuprate Gilman reagents, right? There's none of them here, so we need an enolate nucleophile, all right? So our O-T-butoxy species is going to pluck off a hydrogen, which is resonance stabilized by the carbonyl, and this will give us an enolate that looks like this. Okay, so we have ourselves a nucleophile. All right, now what happens is these lone pairs kick down, reform the carbonyl, okay, and these are going to attack in a conjugate fashion. They're going to attack the beta position of our alpha-beta unsaturated carbonyl, okay, and this is going to give us a new enolate, okay, and now this end carbon at the bottom is going to be bound to our cyclopentanone ring. Okay, now the next step of a Robinson annulation reaction is to have an aldol condensation reaction happen, right? But if we draw it in this particular substrate, this is our nucleophilic carbon, this would be our electrophilic carbon. So there's 1, 2, 3, 4 carbons that would be in that ring, okay? That is not a viable aldol reaction, right? 4-membered rings, as you should be comfortable with now, are very sterically strained or just torsionally strained. There's ring strain along with all the steric strain. Okay, so what happens is that there is a proton transfer where this enolate is going to switch sides, right? So we're going to protonate the enolate that's drawn out here and then deprotonate the other alpha position to give something that looks like this. Oops. Okay, so now we have an enolate here. And now if we count carbons, we have 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, 6 carbon, right? We're always going to make a 6 carbon alpha beta unsaturated carbonyl, okay, ketone, right? And so all that has to happen now is our standard enolate attacks carbonyl. That's the addition step, all right? And then you would do subsequent reactions to do the condensation, okay? And that would give us the final product of that, okay? So again, Here we have our beta position. Here we have our alpha position. So this is an alpha beta unsaturated ketone. It's a cyclohexenone because it's a Robinson annulation. All right. So again, the point of emphasis here: be comfortable with a Michael reaction. What is a Michael reaction? Okay. Be comfortable with what an aldol condensation reaction is. All right. And know the difference, of course, between an aldol condensation and an aldol addition.